Hello, everyone. Welcome to my webinar. In this webinar, we'll be talking about how to backup and migrate Kubernetes applications using Velero and StorageOS. Before we start the webinar, I'd like to tell you that one person that stays on until the end of the webinar will be eligible for a £25 voucher. So before further ado, let's start. First, let's start about me. My name is Angelos Perivolaropoulos, and I am a product reliability engineer at StorageOS, and I work for the PRE team. What we do in PRE is we are responsible for the reliability of the product of StorageOS, and we do this through testing and experimentation with Kubernetes clusters, which means that I spend most of my time working with Kubernetes clusters every day. I create them, I destroy them, I fix them, and I experiment with them. And during my experimentation, I found a very fascinating tool that's quite interesting that actually works very well with StorageOS and enhances a lot of its capabilities. And I would like to give a bit more awareness to it. That tool is called Velero. It is open source, and it is used to safely backup and restore, but also perform disaster recovery, and also can be used to migrate Kubernetes cluster resources, and more importantly, persistent volumes. It also means speedboat in Spanish, so it follows the trend of the C-related names of Kubernetes. Velero is consisted of three components: the Velero server pod that runs in the cluster, the Rustic daemon set that also runs in the cluster on all nodes of the cluster, and the CLI client that runs on the client's machine, in this case, my computer. So let's talk a little bit about how the Velero backup architecture works. Velero works like an operator, which means you create a custom resource. In this case, we create a custom resource by running with a CLI, a command in the form of something like that. Then this custom resource is created in the Kubernetes API, which is being watched by the backup controller, in this case, the Velero server pod. And when it sees a change in the Kubernetes API in the form of a new custom resource, it performs the backup. After it manages to gather all the files and the data from the Kubernetes API, it then uploads them to a cloud provider. In this case, maybe this diagram isn't showing it, but you don't need to have a cloud provider. Any S3 compatible object storage works, which is great for this webinar. There is another very interesting program called MinIO or MinIO, which is a software-defined high-performance Kubernetes native object storage, which fulfills the S3 compliance that Velero needs. And since it's Kubernetes native, it means we can use it with StorageOS by attaching it to a StorageOS volume. And MinIO with StorageOS is able to get the rich feature set of StorageOS, which includes capabilities like high performance, high availability, replication, and also encryption. And in the case of performance, it is significantly higher than S3 since we're using actual disks instead of the cloud storage that S3 provides. So how do you set up Velero Mini and MiniIO? I'll show you now. And for the purpose of this demo, I will also have created a populated MySQL application that we'll be using as a demo. And this will also be backed up with StorageOS PVC. So it's a StorageOS application. So let's start here. I have a cluster, which is a standard Rancher cluster with 4 nodes. And I have already installed MinIO and Velero, so I'll just show you how I did it, just for the sake to not waste any of your time. So you can see here, that it's already set up. The first thing you need to do to set up this configuration is install MinIO. MinIO is quite easy to install because we have all the manifests ready for you. If you go to our GitHub page, the use cases, you can actually see that we have a Velero directory, which includes many different directors I can use to create a setup like this. In this case, MinIO, which you can see here, it's a stateful set, and it has a service and different other manifests. But most importantly, here you can see that it's backed up by a storage class named fast StorageOS volume. It's very simple to apply this. You can just do a kubectl apply. In this case, K would be a shorthand for kubectl in my computer. Just MinIO And then I've already done this, so nothing will happen, but this is how you install MinIO. After you have MinIO installed in your cluster, the next thing to do, assuming you've already downloaded the Velero CLI binary and have it installed in your cluster, in your computer, you only have to run this installation command, which you have to give it the provider. In this case, it's AWS. It's not AWS, it's MinIO, but since it's S3 compliant, we say AWS. Then a bucket name, which is a fake bucket in this case. There's some credentials, which is just the username and password that we use for MinIO. And then the actual URL path, which is the service of MinIO in this case. I've already done this, so we don't have to go through it. And by adding the use Rustic argument at the end, it also installs Rustic for you, which you can see we have already done here. Next thing to do is to install a dummy application, MySQL in this case. Again, I will install this as well in the cluster, just for the sake of making things go faster. You can see here, it has a client and a MySQL database, and you can also find it in the use cases, which I have here. You can see MySQL, it has namespace, and one thing to note in the stateful set, again, we have a StorageOS storage class name fast, which has 1 GB that we're using for the persistent volume. I have already installed. It would be very simple to install it as well. You just do apply kubectl apply .f MySQL, and it will install the MySQL application for you. So we have that ready. Next thing to do is populate the MySQL database. We can do this. We can exec onto the pod, and then we can run some commands. For the sake of this demo, let's pretend that we are a bookstore and we want to create a database for our shop. So we create a database shop, then we use it, and in that we're going to create a table called books. And in that books table, we're just going to add one book, which is called Gates of Fire. And if you can see it here, populated, you can see Gates of Fire. And with that, we have set up our dummy application and Velero and MinIO in our cluster. So moving on to the next part of the webinar, which is how do Velero backups actually work? Okay, you trigger the backup with the Velero CI, but what happens after that? The first step of actually backing up the Kubernetes objects is very simple. You just query the Kubernetes API, you just receive all the objects, that's fine. You just send it to MinIO, that's fine. But how do you actually back up the actual persistent volumes of those applications? The solution that Velero found was using Rustic, which is another open source, fast and efficient backup program. And Velero installs Rustic as a daemon set, so it's able to run on every node on the cluster. Then when a backup is triggered, what Rustic does is it actually goes to the mount point of the selected application that's on disk and copies those data, converts it into blob files in an efficient way without having duplicates, and sends them to MinIO or a cloud provider if you're using that in this case. And also Velero backups can also be scheduled and performed on a regular basis. So all this I'm sharing to you right now, you don't have to manually do it every time. You can just schedule it once a week or once a month, whatever works best for you. And now some of you will be quite curious because they'll be thinking, okay, you're trying to back up applications that are active and running at the same time. And you'd be correct to ask a question of what about data that's in flight? If you try to back up an application that has data in flight, during your data, during your backup, if there's data that are coming into the application, that means that all your backups are going to be corrupted. So how does Velero solve this issue? It's with a concept called quiescence. What quiescence is, according to the Oxford Dictionary, is inactivity or dormancy, or more, it's closer to temporary inactivity or dormancy. So in this case, it would be the state of being temporarily quiet or not active. And Velero allows you to do this by giving you the functionality of adding pre and post backup hook commands in your application. What that means is that you can run a command before the backup and after the backup. In our case, we're going to be using a freeze and unfreeze of the file system. So we can freeze it to make sure that no extra data is coming into the application, backing it up, and then unfreeze the file system to allow the application to continue running as it was before. So let's actually do that, and let's do a backup. So as I was showing you earlier, the way to do this is by going to the stateful set manifest, which we have here. And in the annotation, the first thing to do is add this annotation here that will allow Velero to understand which persistent volume it will try to back up. So in this case, we have a volume called data, and we're backing up by adding this annotation. And then the next thing to do is to add a pre and post hook command, which in this case we do by commenting this, which is just an fs freeze on the var lib MySQL directory. But to do an fs freeze, we need to be able to have a container that is able to do fs freeze. And unfortunately, the MySQL container by default is not able to do an fs freeze. So we need to add an extra container into that pod, which we're going to be calling fs freeze in this case, which is very simple. It's just a Debian container that just sleeps. That's all it does. And the only reason we need to have that is to be able to run the fs freeze command. So let's do that. If we apply, as I was showing you earlier, and we're going to see now that the MySQL service will start first. It will get terminated, and then it will get recreated. While we're waiting for this to happen, I want to show you a little bit more things about what else you can see in the use cases of StorageOS. Other than the Velero, there's also different uses you can try, like Elasticsearch, Cassandra, and of course your own MySQL if you want to try that, and Prometheus. And all of this you can find on our GitHub page. And also you can find more information about that in our docs, in docs.storageos.com, docs use cases. So hopefully now this will be created. That's great. So if we exec again on that MySQL container, let's see, this is using a StorageOS volume. So it's using persistent stateful. It's using a persistent StorageOS volume. So we should still see the data that we had earlier. Okay, that's amazing. So we can see that we still kept the data even though we recreated the application. Great. Next thing to do is actually perform a backup of this application. This is quite easy to do again. We just need to run the following command, which is this one. So as you can see, this is called Velero backup create, and then the name of the backup, and then what you want to backup. In this case, just for the sake of being able to include everything, we include the whole namespace. But you have the ability to select specific pods, services, or whatever you want to do. In this case, I just backed up the whole namespace. And if we actually have a look at what happened, you can describe the backup. This takes a little bit of time. But while we're waiting for this, it should take a few seconds. Yep, you can see the backup was completed without any errors. And you can see that what was included was the namespace of MySQL. And you can also see that the Rustic backup was also completed of the MySQL, of the data volume of the MySQL. Next thing to do, let's say now our intern that we hired a new intern, and this intern doesn't really know how to use Kubernetes very well and accidentally deletes the MySQL namespace. So while waiting for this to be deleted, let's go on to the next slide of now we have a problem, we have a disaster, our site is down, our shop is down. What do we do? Well, now we have a backup. So next thing to do is to actually do a restore. So how do Velero Restores work? Well, you again need to run a CLI command. In this case, it will be Velero Restore. And this Velero Restore will create another object in Kubernetes that the backup controller is going to be watching. That is called a restore object. And then this restore object will be connected to a backup that you want to restore. And for each object in the backup, the Velero will check, does the resource exist that we're trying to restore? If it does exist, do nothing. So you can't recreate resources that already are in the cluster. If the resource doesn't exist, then and it then doesn't include a volume. If it doesn't include a volume, you just recreate the backup from the manifest. It's very simple. If it does include the volume, then you recreate the resource, but you also add an init container that basically copies the backed up volume files on the mount point of that pod. So it's able to actually copy the data into the new volume that is created by the backed up application. So let's see how that works in action. We should have namespace deleted. So let's double check that it's actually deleted. Yep, nothing here. So let's try to restore it. So it's restore, create from backup. This will take a little bit of time as well because it's time to restore. So while we're waiting for this to restore, I can show you how it looks like on MinIO. You can see here, we can see like that it includes the backups. In this case, this is the backup name that we used. And you can see all the files that are being backed up. And also on Rustic, Rustic is using snapshots to back up to be a bit more smart with how it uses the data. So instead of having a specific backup name, it only has the application name. Hopefully now it should be restored. So let's check. Yep, the pod were restored. And let's check if the data is again there. And it's here. We managed to delete the namespace, and using Velero Restore, we're able to recreate the lost data. I would also like to note that the PVC was deleted as well with the namespace deletion, because PVC is part of the namespace. So it's not about persistence. We actually restored from a backup. So after the successful backup, what's next? Well, there's also another way you can use Velero. You can actually use it for migration other than backup and restores, which is a similar process, but instead of backing up and restoring the same cluster, you back up from one cluster and then you restore from another cluster, which in a way, this is a migration of that data. Unfortunately, we can't use MinIO for this because MinIO is not multi-cluster. So for this application, we're going to use the actual real S3 bucket. And again, the same MySQL application that uses StorageOS. However, there needs to be a requirement for this to work. When you need to have, the resources need to be able to be recreated. So for that to happen, you need to have StorageOS installed and have the same storage class in that cluster. And also, Velero needs to be installed with the same backup location. In this case, the backup application we're going to be using is not MinIO, but an actual S3 bucket in AWS. Now I can show you how this can actually happen. First, just to give you a very brief explanation of how this is installed, installing with an S3 bucket is super simple. You only need to run one command, which in this case is just this. You just have to tell it what your backup bucket name is and the location of the bucket, and it will do the rest. I've already done that. So if we actually see this cluster I have, it's called webinar 2. And then I have another cluster here, which is webinar. So we have these two clusters that are both running Velero and StorageOS. And you can see that the backup location, this is another object from Velero. The backup location is in this bucket, Velero webinar backup. And in this, if we look at here, again, Velero webinar backup. Okay, next thing to do is check the application that we have. So again, I have already installed, just for the sake of making things go a bit faster, I've already installed a MySQL application that holds exactly the same information as the other one, although it's a different cluster, again, as I was saying. So if we go and do shop and then select from books, you can see again the same book, Gates of Fire, but it's a different cluster this time. To give you an idea, this cluster is webinar 1. This cluster is webinar 2. And this cluster is webinar without any 1 or 2. Okay, so let's back up our file again this time. We do a Velero backup, again, create. You have to wait for it to create the backup. And while waiting for the create backup, we have another disaster happening. We have one of our interns, instead of after we revoked his permissions to actually after we revoked his permissions to not have access to Kubernetes, he actually still has permissions to access Rancher. So what he does, he actually deletes the whole cluster this time. So while I'm deleting the cluster, you can actually see here that it's soon gonna be deleted. Yep, the cluster is gone. We no longer have any connection to the cluster. Everything is deleted. But what do we do? Thankfully, we have another cluster already here. And since we're using Velero, we can actually see that it has the backup that we're using earlier. So we can actually migrate the data onto this new cluster. Same process as before, just to give you an idea that the MySQL data is not there. You see there's no pods in the MySQL, and there's also no PVCs either. So let's actually restore the data from there. So again, restore create from backup. This is gonna take, again, a little bit of time, but yes, this basically gives us the opportunity to, except of disaster recovery, we can also use the same process to migrate applications from one cluster to the other. For example, let's say we have a production cluster, and then we have a sandbox cluster that we need to use to shadow traffic. We can very easily just migrate everything from one cluster to the other without worrying about what kind of manifests there are, where those manifests are, where the source control for that is. We just run Velero, do the backup, restore to the next cluster, and very easily this process can be done. Here we can see it's going to be getting recreated. Pod is initializing. This is going to take a little bit of time. And again, as you saw, if you had noticed, the restore took way longer for the S3 cluster than the StorageOS with MinIO cluster. This is because you would expect to be a bigger discrepancy. You would expect storage much faster, but because if you're using much bigger files, in this case, we only use a few megabyte databases. If you use much bigger files, the difference would be astronomically different because S3 is much, much slower than, of course, StorageOS. So let's see if the pod has managed to finish. Yeah, it has. Let's check if the data is now there. Yep, and our database was managed to be saved, and probably somebody should revoke the permissions of that intern. And this is the end of this demo. I think that's all I have to say about Velero. If you liked what you saw here and StorageOS seemed interesting to you, feel free to go to our site and try it out for yourself. It's a really great tool. Even though I work here, I can actually say that, especially in the latest versions, I'm really proud of what we have here. So if you're interested and want to try it out, I think it's worth a try. It's very easy to install as well, so why not? So make sure to go to our site. For some further reading, if you want to try, we have some performance benchmarks in this URL, some idea of how our architecture is like. We can find this link. Our documentation with is docs.storageos.com, which will include the use cases I was showing you earlier. And if you want to talk to us, and if you want to talk to me as well, you can go to our Slack, slack.storageos.com, and you can speak to one of our engineers, or if you have any questions about your installation, we'll be very happy to help you out with everything. So thank you all for listening. Does anyone have any questions?
Thank you, Angelos. That was great. We do have a question. Can you see it in the Q&A?
Yes. When you mention MinIO cannot be used during the cluster migration scenario, I use MinIO for this scenario, it works fine. Can you please elaborate if any issues? So in this case, MinIO lives in the cluster that maybe your setup of MinIO would be different than mine. In my setup of MinIO, the MinIO lives in the cluster with a StorageOS PVC. So because of that, it can only be accessed within this cluster. If we want to migrate an application, from one cluster to the other cluster should be able to contact MinIO in this case. But if MinIO is only accessible in that cluster, it's not possible. In this specific scenario, if you're using RWX volumes or an NFS service or something like that, it is possible, but not in the scenario I was talking about. Another question I have here: does StorageOS work on K3s? Yes, it does work. The only thing is that you might need to do some manual configuration with the paths. I think kubelet is different it has different paths, so you need to manually add that difference path. If you have any problems installing it, you can send us a message in slack.storageos.net on our Slack, and we can help you out with it. But I have managed to get it running on K3s.
Perfect. There's just another question here. Can all stateful Kubernetes applications be backed up using Velero?
So from what I've tried, most of them can, maybe 99% of them. There might be some that don't, because in this case, what Velero does is just copy and pasting the data from the backup to a new application. Most of the times, this will be fine, and the application will be able to start normally. But there are some applications that won't be able to do it. Very few though. From my end, I haven't found any. So if you'd manage to find any, please let me know. I can see another question. When you freeze the MySQL in your example, the MySQL is working or not? So when you freeze a file system and you try to make a write on it, it will wait for the file system to unfreeze before it succeeds with a write. So it depends on what timeout you're using and how long the backup is going to take. If the backup is fast and your query doesn't time out, then it will just have a small delay and then continue working. If your application times out during that time that the file system is frozen, then most application will just retry after a few seconds. So it is a very small downtime in a way, but you try to make it as small as possible while be able to do the backup. I see during your backup, MySQL is quiesced. Does that mean MySQL is not available during time of backup? Again, like I was saying, that you can't have a backup without quiescing. So you need to have this small downtime. The Velero just tries to minimize as much as possible with the pre and post hook. With pre and post hooks. It's an incremental backup. For Rustic, yes, it's a snapshot. So when you're using Rustic for the actual persistent volumes, then it does an incremental backup as a snapshot. Any benchmark data of how long a backup will take? Say database is 500 gigabytes. I don't really have that information right now. I did try it, and it took, I think, around 30 seconds or something. But for MinIO, but again, I don't have actual. I didn't benchmark it.
Cool. And then just one more question, if you don't mind, Angela. So can you back up applications that use encrypted volumes as well?
Yes, you can back up applications that use encrypted. Using StorageOS would be the example I would, encrypted through StorageOS would be the example I would give. The only thing you need to keep in mind is that if you're backing up the whole namespace, the encryption key will be backed up as well. But when the new application is getting restored, a new encryption key is going to be created. So just make sure that you don't have any spare encryption keys in your namespace. Just do a double check, or instead of using the name, just backing up the whole namespace, make sure that you're backing up the only things that you need. but encrypted data will be able to be backed up, since you're actually backing up the mount point itself, not where the data is on StorageOS.
Sure. And can you have multiple backup locations?
Yes, you can have multiple backup locations. The only problem with multiple backup locations is that, unfortunately, Velero only uses one one set of cloud certificates. So all your backup locations need to have the same cloud certificates. If you're using, for example, multiple MinIO installations, they just need to have the same password and username. Which means it's a bit difficult to do having MinIO and an S3 bucket at the same time. Not impossible. I've managed to get it working. You just need to do a little bit of hackiness for it. Another thing, you may provide this. I have tested with 300 gigabytes, which takes 2 hours to back up. Restore takes 1 hour. Perhaps I have to do the benchmarks myself, but it was surprisingly fast with StorageOS, I must say, with doing the Velero backup. Maybe I could provide some more benchmarks next time.
Cool. Well, if there are no further questions, thank you so much, Angelos, and thank you everyone for listening. In terms of the Amazon voucher, congratulations to Neil Patel. We'll be in touch with you in due course about how you can get your voucher. And thank you all for listening. We will be sending out a post-comms with all of the slides and the recording, should you wish to watch it again. And please watch out for the next webinar in the series that will be coming next month. And we look forward to seeing you all again. Thank you for listening, and thanks again, Angelos.
Thank you, everyone. Bye-bye.